already this morning and every day you guys hear all sorts of excitement and hype around AI. It's going to change everything. It's going to change your industry. It's going to come for your job. There's all sorts of exciting opportunities here. And at the same time, there's a little bit of a fear, right? What's left for us? If the machine's intelligent, well, what do humans do? What can we do? And underlying all of this debate is some sense of a big question, which is, what is AI? If you read the press, The Economist accepted, of course, it seems like we're debating between whether we're going to get C-3PO or Skynet from the Terminator. And either of those seem a little scary. But that's not really the technology that's gotten us excited about AI over the last few years. It's not crazy, but it's not why we're talking about AI today in 2018. The reason we're talking about AI in 2018 have been massive advances in the capabilities of machine learning. And so me and my co-authors have been privileged to watch this advance in machine learning in its capabilities from the beginning. And the reason is we're at the University of Toronto, and usually at the University of Toronto we don't get to say, hey, we were first at much. But in deep learning in particular, we had a lead. And people who had been affiliated with our university ended up running AI at Facebook, at Apple, at OpenAI, and a whole bunch of other organizations. And in particular, the three of us run a program for helping early-stage startups scale. And starting in around 2012, there were these startups that called themselves AI companies. I thought, that's interesting. Got to get our heads around that. How can we understand what that all means? Now, the three of us made our careers as economists studying the previous generation of technology, studying the internet. Looking around the room, it looks like in this audience, most of you do remember 1995. And that year was a very exciting year. That was the year that the internet hype started. That was the year that Netscape had their IPO. They were valued at over $1 billion with no profit. I guess now that's not so unusual, but in 1995 that seemed crazy. It was the year of Bill Gates' internet tidal wave email, in which he said, Microsoft as a company, we have to change direction and focus all of our efforts on taking advantage and playing defense against this new technology. Everybody said the old rules didn't apply. They started talking about a new economy. This was different. Everything that you knew, that you learned in your economics classes, the pundit said, was garbage. Now, of course, there were one group of people who said, no, 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 it's not a new economy. It's the same old economy, just some things have changed. The cost of some things have fallen. Of course, that group of people was us. It was the economists. We said, no, 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 the rules of economics still apply. Just recognize that the cost of search is cheaper, the cost of communication is cheaper, the cost of copying is cheaper. And once you understand that, all of the consequences with respect to the death of distance, with respect to piracy, with respect to privacy become obvious. So understand that what the technology changes, what cost falls, and simple economics tells us what's going to happen. When the cost of something falls, we do more of it. You might remember from your Econ 101 class that idea. It's called demand curve sloping downward, right? When the price of something falls, quantity goes up. When the price of search fell, we did more search. And so when we try to understand technologies as economists, the way to think about it is what's changed, what cost has fallen. Go back a technological generation and think about the semiconductor. What does a computer do? Really fundamentally, what does a computer do? It drops the cost of something. Turns out it's something really important. All computers do is arithmetic. That's it. When you use a computer to send an image, to write an email, to play a game, all of that, it's just because arithmetic is so cheap that there's all these crazy applications for arithmetic that you might not have dreamed of. Cheap arithmetic is extraordinarily powerful, and it's so powerful that we start recognizing opportunities for arithmetic in places we might not have dreamed of. And so, when we think about the opportunities For arithmetic, the first applications of cheap arithmetic were things like artillery tables and accounting. We had cannons, they shot cannonballs. It turns out it's a pretty difficult arithmetic problem to figure out where those cannonballs are going to land. We used to have humans, who we called computers, you might have seen them in the movie Hidden Figures, that figured out where the cannonballs were going to land, did that arithmetic problem. We had machines replace it, and the machines did the arithmetic instead. If you asked an accountant from the 1940s and 50s what they spent their time doing, they added. That's it. They spent a lot of time adding numbers. Accountants don't add anymore. That's because machine computing, machine arithmetic is so cheap, it's crazy to have a human do that kind of arithmetic. But it turns out as the cost of arithmetic got cheaper and cheaper and cheaper and cheaper through the 70s, 80s, 90s through today, we got games turn out to be an arithmetic problem. Mail's an arithmetic problem. Music is an arithmetic problem. Pictures are an arithmetic problem. All these things that you might not have thought of as arithmetic problems, once the cost of arithmetic gets cheap enough, we recognize they're arithmetic problems. That gets us to today's technology. This is a representation of a convolutional neural net. That's some of the technology underlying a lot of the recent excitement in AI and machine learning. What is this doing? It's doing prediction. AI should be thought of as a drop in the cost of prediction. Not all AI, but when we think about what's changed over the last few years, why are we talking about AI in 2018 when we weren't talking about it in 2008? It's because prediction technology has gotten better. And it's gotten much, much, much better. So what should we expect to happen? Just like with arithmetic, just like with search, just like with copying, we should see more and more of it. We're going to see all sorts of applications for prediction that we might not have dreamed of. And it turns out prediction's pretty important. Prediction's using information you have to generate information you don't have. Well, that's a fundamental input into decisions. And since decisions matter, cheap prediction is going to have all sorts of applications. The first applications have been classic prediction problems. Someone comes into a bank, they want a loan, the bank needs to predict whether they're going to default. That's a prediction problem. It's an old-fashioned prediction problem, and we're using AI to predict it better. Insurance risk, whether someone's going to make a claim, is an old-fashioned prediction problem, and we're using AI to make those predictions better. But what's interesting is over time, as prediction has already gotten cheaper in the last few years, we've recognized a whole bunch of things as prediction problems that you might not have thought of as prediction problems. Medical diagnosis is a prediction problem. The doctor takes information on symptoms and figures out the cause of them, predicts, fills in the missing information. Object classification is a prediction problem. Your brain takes signals on what it sees and identifies it, labels an object, and understands the context. That's filling in missing information. It turned out a lot of the advances in autonomous driving recently have been because of the recognition that driving can be reframed as a prediction problem. And a pretty, perhaps frightening prediction problem. Predict what a good human driver would do. So once we're predicting what a good human would do in various situations, we can get a sense there's a lot of opportunities for prediction, for cheap prediction that we might not have dreamed of. And we're only a few years into this. Who knows what's going to happen over the next years, decades, and beyond. So prediction is valuable because it's an input in decision-making. Decision-making is everywhere. But importantly, for your organizations, in terms of the assets you have, and importantly for you, in terms of the jobs you have, prediction is not decision-making. There are other aspects of decision-making, and these matter. So the other Econ 101 concept I want to remind you of is, okay, when the price of coffee falls, we buy more coffee. That's demand curves. We buy less tea, sure. But we buy more cream and sugar. Cream and sugar become more valuable when coffee is cheap. So the question you need to ask yourself is, do I have the cream and sugar for AI, for prediction, in my organization or in my skill set? The way to think about the cream and sugar, the core complements to prediction, are thinking through what are the elements of a decision. The most obvious, and you've already heard it talked about lots this morning, is data. Okay? So there's different kinds of data, input data, training data, feedback data. These are core complements to cheap prediction. In the absence of data, your predictions will not be very good. Actions, actually being able to do something with a decision, is a key complement to prediction. Otherwise, what's the point? And finally, what we label judgment, which is the ability to know which predictions are going to matter to you and your organization, and what to do with them once you get the number, once you get the prediction. So it's just a matter of time until things that you do and things that your organization does are going to be done by prediction machines. The question you actually need to ask yourself isn't if, it's a when. When do I need to make sure I have these complementary assets in place in order to take advantage of cheap prediction and potentially make strategic changes to what I do? If it's in the next 6 months to a year and you haven't started, you're probably in trouble. If it's 3-4 years from now, you have time, if you jump on it, to make those changes. And if it's a decade, well, you can wait and see how this all plays out. Your thesis on when this is going to matter is key to how you make your decisions to invest in those complementary assets. So here's how we like to think about it. We like to think about this as a thought experiment. Turning up the dial on prediction, just like you'd turn up the volume on a radio. Currently, my sense is prediction machines don't really seem that good. I don't know if maybe that's a theme that we've heard today, that there's all this excitement about AI, but if you think about Amazon's recommendation engine, they're right at best 1 out of every 20 times. They make 20 recommendations, maybe one's right. Their recommendations for me are some combination of AI books and video games. Ostensibly, those are for my children. And that's it. That's cool. Oh, wow, how did they do that? They have millions of products, but it doesn't really seem fundamentally transformational. So given that, Amazon's business model is a lot like Sears' business model 100 years ago. You go to their catalog, you shop, they send it to a warehouse and mail it to your house. You shop, then they ship. Now let's run this thought experiment. Let's turn up the dial. Let's turn it all the way up to 11 if you want. See what happens. Well, now the business model can change. Now they don't need to wait for you to tell them what you want. They can predict it. They know it already. They can just ship it right to your house before you even know that you're going to want it. And so that prediction machine changes the nature of the business. They now need to invest in making sure they might not be right 100% of the time, so you shop at the door. They ship, then you shop, and they need to have some system for returns. The business model changes because prediction gets so good. That will happen to a lot of you. And the question is not if, but when. And in case you thought that was science fiction, they do have the patent, and they filed for it over 3 years ago. Okay. So there's a bit of a dissonance here. If we look at the AI products in the world today, a lot of them are fine, but they're not as exciting as you might expect. They're kind of meh, right? But if you look at the hype, VC investment in AI is going like crazy. Google and other companies said, we're AI-first companies. We're willing to sacrifice the customer experience in order to improve our AIs and have our AI learn. It's a big step. The government of China has invested billions and billions and billions and billions and more in getting to be #1 in AI by 2030. And of course, Vladimir Putin said the country that controls AI is going to control the world. How do we make sense of that dichotomy between what we see today and the future potential? That's a question about your thesis, about how quickly that dial is going to turn. If it's slow, then you're fine. You can wait and see. If it's faster, or if it's happening immediately and exponentially, then you really need to think through what you can do now to change your behavior. Thank you.
I'm going to take the chairman's prerogative to ask you one question.
Shoot.
Before we go to the break. You're an economist.
I am.
You're part of a team of economists, which we respect and appreciate. A number of economists have looked at technological advances of the last 20, 30 years, most notably Robert Gordon, but Tyler Cowen and others have argued, this is all cool stuff, but it hasn't improve productivity. We don't see it in the figures. What is your prediction as our economics AI sitting on stage for whether this wave of artificial intelligence, as it becomes absorbed by industry, will in fact increase productivity, or whether we'll see a repeat of previous trends?
So Bob Gordon was my professor, actually.
So there you go. Here's your chance to make your own way in life. Step out of his shadow.
I think, so AI is what we call a general purpose technology, which means it takes time to figure out how to use it. And so
Give it 30 years. I'll give you a long runway.
Then we are going to have massive improvements in productivity.
Okay. That is
and
a
I can
very
go into
clear
why, if you're
prediction.
curious.
We'll return in 30 years and we'll hold you to it.
Excellent.
Again, another round of applause for our guru.